Okay, so today we'll be talking about Google advertising. Ta-da. Okay, so a couple things, revenue models and fraud detection. And we'll get to, after we've talked all about how Google does their stuff, we'll talk about APIs, application program interfaces, or programming interfaces, and some of the databases systems that Google uses to support what they do. All right. So, advertising revenue. Most people, when they think about Google, they just think about the search engine. They think, well, that's what Google does. And that's not wrong. It is one of the things they do. Some people think of it as a whole bunch of cloud-based applications, right? Like G Suite and some other more advanced ones for businesses. Lately, they've been getting some headlines with self-driving cars. And yeah, it does all those things. But more than anything else, Google is the world's biggest advertising operation. This is an old number from a few years ago. Nowadays, the annual revenue is closer to 125 billion a year. So that is a lot of money. For those of you who watched Breaking Bad back in the day, that's fat stacks right there. And the crazy thing is, Google doesn't even make the ads. Basically, they're a $125 billion billboard operation. So, basic model for it, right, from way back when, their first step, bringing people to use the search engine, right? And if you were doing those like 1, 2, 3 things to make lots of money, it would have looked something like this, right? 1, get people to use our search engine. 3, make lots of money, right? And then the big question mark in the middle, how do they do it? Well, the way they do it is by running ads primarily when people use search. So, what's really it? Run ads along with search results. Okay, so that's their basic framework for making money. So, key things. Number one, Google wants to show ads that align well with the search terms. So if somebody's doing a search for, say, sandals, Google's going to show ads for sandals. If somebody's doing a search for hotels Chicago, Google's going to do a bunch of ads for hotels around Chicago. So that's what we mean by aligning that. So it shows those ads along with the search results. And in most cases, the model is when users click on the ads, Google gets paid. That's what's called pay-per-click or PPC. So, core questions for Google. Number one, how to figure out which ads are aligned with which terms, right? I mean, for something like Chicago hotels, it's pretty easy and obvious. For other things, that could be a little murkier. For example, if I am looking for, let's go to Google, and let's say that what I'm looking for is windshield wipers. Yeah, I see some ads for that, right? But how does Google know which brands are best, or which sizes to show, or which retailers to show them from? Okay, it has a lot of options there. How does it decide the order? Which ones go at the top? Maybe there's some down at the bottom. I don't know. Not really. Okay, but that's how it does it. And if we go to the second page, I'll probably see some different ads. Yep, different ads, right? And some in the side. Again, Google's put a lot of thought, a lot of algorithmic work into figuring out which ads go where. How do they decide? And last, setting the right price for clicks. Okay? How much is a fair price to charge? Well, the short version there is Google lets the advertisers bid against each other for space on the pages. And whoever throws in the most money and is correlated with the best ads, that's what gets shown. So, straight into the bidding model. The key factor in Google's bidding model is what's called a quality score. Google assigns every ad a quality score, which encompasses, number one, as a baseline relevance to search terms. So suppose the search terms are windshield wipers. Obviously, an ad that has the tag in it, windshield wipers, is going to be pretty relevant. An ad for, say, umbrellas, not so much. Okay, so that's how relevance is. But again, that's only a baseline because there can be lots of windshield wipers. So how does Google differentiate among all of them? Well, one of the big things is how often users click on the ad. Why is Google worried about that? Because when users click on the ad, what happens? Why does Google care if users click on the ad? Google's not selling the windshield wipers. What's that? Google gets paid, correct. Okay? When somebody clicks on the ad, Google gets paid. So Google wants to show the ads that get clicked on more so that they can make more money. Yes. And on top of that, how often the ad leads to a purchase. So Google has a lot of web analytics, it has web analytics software that is used by many, many people. And one of the things that Google tries to get retailers to do is run Google's web analytics software. So basically they can see what people are doing on their website and how often ads lead to purchases. So the retailers see that information and can verify that, yeah, it's good business to advertise with Google, but Google also gets this data. Google can also see, we know that this ad, somebody clicked on it, they bought the product that same day. This is something that's valuable to the advertiser. The advertiser will be willing to pay more. We want to show this ad, okay? It's better to have one click and one purchase than 1,000 clicks and no purchase. But a lot of times Google doesn't have all that purchase data, so they work with what they have. Okay, does that make sense? It's a pretty simple model if you break it down. Anyway, so Google wants to show ads that are likely to lead to long-term revenue, which basically means ads with a high quality score are going to get display priority. They're going to get shown at the top of the first page of search results. Ads with lower quality score, maybe at the bottom of the first page or on the second or subsequent pages. Okay? The other thing, bidding. So, if you're an advertiser and you really want that top spot, Google will take your money and let you have that top spot. Okay? So, there's basically two ways to get to the top of the page. Number one is to have a quality score that's so far above everybody else and nobody's outbidding you. Or number two, to have a higher bid to run your ad to make up whatever difference there is in quality score. Okay? So either way, there's two ways to do it. And the idea there is basically Google wants to make money. Google's going to figure, well, you know what, if you're willing to bid a lot for that space, maybe you know better. Maybe it is actually worth your money to do it. But regardless, they'll take your money to do it. The search results themselves remain pure, but Google will take your money to run ads in different places. Okay. I should ask questions on that? This is pretty fundamental. If you understand this, you're about halfway there. Okay. Nothing? All right. So, Google has two categories of ads. Number one, ads that run on its own site, that run on Google.com or subsidiaries or close partners, right? Think like YouTube, which is part of the Alphabet group, that's the umbrella organization that holds Google, and some of the other ones. The other, third-party sites. Third-party sites have agreed to run ads selected by Google. So for this, think bloggers, right? You run a blog, you want to get money to pay for pizza, you tell Google, yeah, you can run some ads on my blog, and if people click on them, you'll eventually get paid. All right. And this advertising split, there's two main models for it. So AdWords is the ones that get shown along with Google search. AdSense is the ones that get shown along with third-party operations. Okay? Again, repeat, Google search results are pure. You can pay money to get your ad shown in a better position, but Google always shows the search results as far as showing what people actually click on, what it thinks people actually want to see. There's no way you can pay Google to have your search listing for your site rank higher. You can pay to have your ad rank higher. Okay. Excuse me for a second, I gotta blow my nose. I'm getting over this cold, but boy, it is slow going. All right. So, talk about AdWords first. In AdWords, advertisers pay for ad placement with some search terms, right? Basically, the advertiser thinks to himself, this is my product, picks a bunch of search terms that correlate with that product, right? So, suppose your product, let's make that a bigger font. All right. Suppose your product is windshield wipers. Obviously, you'll advertise with the search terms windshield wipers, right? And probably wipers, because people might do that. What else might you pick? If you are an advertiser, what might be plausible? Anybody know a windshield wiper manufacturer? Who is the most trusted name in windshield wiping? No? Nobody know? No, just windshield wipers are just something that happens. They on your car, you don't know how they get there. No, you get... Yeah, well, that's all right if people don't pay attention. I'm just, you know... There's Michelin, there's Rain-X. Which one do we use? I know the box when I see it. It's not Rain-X. Duralast, I don't know. Okay? Well, depending on who's manufacturing them, you might include, say, your own operation, like say your Duralast, like, right? Duralast wipers. You might also pick a competitor, right? Suppose it happens that Michelin sells the most windshield wipers of anybody. Then you might actually have your ad run with them. Okay? So that if someone searches for that brand, you might have a chance to poach a sale, right? If they're getting a lot of traffic for that, and you can see this. For example, one of the big cloud operations, right? Amazon. If I do Amazon cloud migration, last I checked this, I saw Accenture and a few other ones in this. Okay, Amazon is up there, but there's also this one, Avaya.com, Practical Guide to Cloud Migration, Cloud Migration Strategies. What do we have down here at the bottom? Some more at the bottom. PagerDuty, LogicWorks, At Scale. There's a bunch of other operations that bid on the terms Amazon Cloud Migration because they think, yeah, that's going to get a lot of traffic. And if we're saying, oh, here's a book we can sell or some ebook we can sell to help people out with that, maybe we could sell that. Here's a competitor, they can help out, or yeah, these guys are actually like helping people do it for Amazon. They're doing the work for you, supporting services. You get the idea, right? It's not just selling your own product, but sometimes you find, you know what, we can piggyback on our competitors as well and get some of their traffic. Okay. Anyway. So advertisers pay for ad placement with sorted search terms. They pick search terms that make sense. And then, depending on how good a match Google feels the ad is for that set of search terms and how much the advertiser is willing to bid for each click, Google will take that entire stack of possible ads and pick a few to put at the top of the page. Now, over the last 20 years or so, AdWords is almost 20 years old. When it first started out, not a lot of people used it, so you didn't have to bid very much to get a good position, even on pretty popular terms. Nowadays, there are so many operations chasing, that finite set of terms. Costs go up, right? Because for any set of search terms, if it's like a popular one, like say, shoes, right? There's a lot of search traffic for shoes, and there's a lot of operations that are bidding to have their ads run with shoes. Well, they better be sure that people actually click on these because they're going to have to pay a lot per click to get up there. All right. So, for everybody that wants to be at the top of the page, there's only one spot at the top of the page, and basically your ad has to outperform them and or you have to outbid everyone else. And the more people are chasing that, the prices are going to float up. Okay? Likewise, free Google Analytics. Google Analytics is their web analytics tool. More people using it means more ad users. This was the real marketing reason why Google gave, this is free. Okay? It's a free thing that you can get. Actually, I have an account. I run a crappy website, a very crappy website for Corp. I have DougCorp. All right, this is a little site that I just slapped together some stuff to try out web analytics things on. So DougCorp prepares your child for success. You get the idea. Anyway, but all this stuff I feed it into my Google Analytics, and I can see what people are doing on there. So if I go to analyticsgoogle.com, I can see all my account stuff on there. It's pretty inactive now because I only do anything with this in the off season, during the semester. Although I do get some bot traffic over the summer. There was one summer that I got a whole lot of traffic out of Moscow for some reason. They were like scouring the internet. Okay, but this is Google Analytics. Basically, I can see who's done what stuff on my site. And none of this is terribly interesting, but anyway. So, point is, and I have a bunch of student accounts here too. There's Doug Corp. Okay. Oh. There's my Doug Corp data in just a second. There we go. And there's not much going on there. But the point is, you can track what all is happening. Ooh, look, there's 2 users. Yeah, somebody else is looking at Doug Corp right now. Holy shit, is it you? No. That's unusual. Okay, but I'm one of them. All right, so you can see who's doing what on your site. And this isn't the web analytics class, but the point is, this software is free. Google wants it to be free so that people who are advertising with Google have an easy tool to see the results of their advertising. Okay. So, because of these 2 factors, because it's gotten much more expensive over time, basically, site owners have 2 things they have to do. Number 1, design their site to improve relevance. So if you're selling windshield wipers, you want your site to be designed to get people in there without having to pay for ads, right? Basically, you want to have your site be geared around windshield wipers so that maybe instead of having to pay for an ad and pay a lot for it, your ordinary site ranks high enough that, hey, you know what, our site is there and it's not even an ad and we're getting good traffic off that. The other one, you have to pay more attention to ad effectiveness. You have to be a lot more choosy about which ad terms work and which don't. For example, in 2001, right, with low AdWords usage, maybe a shoe store in downtown Chicago could bid on Shoes Chicago and make money because there's not that much competition, right? But by 2018, right, probably have to be much more selective. For example, men's shoes, downtown Chicago, Michigan Avenue, right? That's going to narrow down the field a lot. Or what else? Women's shoes, Nike, downtown Chicago. Right? Something like that is going to get a much smaller slice of traffic than that. So this, even though, yeah, it would be nice to have your ad listed well with that, it's going to be cost prohibitive. There's no way you can afford that. But something like this, yeah, you're not going to get as much traffic. But people who are searching for this, oh, you know what? I'm downtown Chicago. I'm going to Michigan Avenue. Where's a good place to buy men's shoes? Yeah, you might get better traffic from that for a lot less money. That's the other problem. Shoes Chicago, unless you're like Chicago Shoe Superstore, you're not going to get enough sales off of this to justify the bid, right? If you're some small boutique-y place on Michigan Avenue and you're getting all the traffic for Shoes Chicago and you're paying like $2 a click for that, forget it. You're never going to make your money back. One of these, yeah, maybe you do. Okay. Does that all make sense? Okay. So, moving on. All right. So AdWords history. Number one, the technology actually originated in 2000 outside of Google. And I'm not saying Google stole the technology, but I'm not saying that either. What we do know, there were some idea ownership lawsuits that were settled out of court. Google gave some people a bunch of money. Okay? In a lot of the tech field, it's really hard to distinguish intellectual property theft from independent development or some other things. What can often happen is you get a few engineers and they're having some drinks in Silicon Valley somewhere, And one of them says to the other, oh yeah, we got this neat thing we're doing, and I won't tell you exactly how it works, but yeah, this is the idea, right? And then the other team runs with it. So, but stealing technology is a glorious tradition of the tech world. And sometimes even when it's not stolen, it feels like it's stolen. So you guys know about the whole Facebook thing, right? You guys have all seen The Social Network, the movie? And you know that he was with a couple of dudes on the rowing team that wanted to set up a site, and then he ended up running with his own site while telling them he was, oh yeah, I'm working on this, I'm wrinkling the bugs out. And you guys may know that Zuckerberg paid those dudes something like $50 or $100 million eventually. That happened a few years ago. Microsoft Windows. Microsoft didn't even develop Windows in-house. Basically, they contracted another group and said, hey, could you design a user interface that works like this? And the other team said, yeah, okay, we'll do that. And Microsoft paid them to do it, but they never told them that it was going to be like the core thing, the core innovation of the Windows experience. So that's not quite theft, but definitely, yeah. It's like if somebody says, hey, can I take your picture for $10? And you're like, yeah, okay. And then, you sign away the rights on it, and then they use it in a big advertising campaign worldwide. And you're like, shit, I just got $10 for that? All right. Anyway, same thing. There were a bunch of other businesses going on at the time trying to figure out ways to make money off of search. Most of those did not survive the dot-com bust. Okay, so you guys are probably vaguely aware that in 2001, the internet market kind of melted down and stocks dropped by like 80%. And it was a bad time to be a dot-com business. Anyway, currently, similar business models are operated by Bing, and Yahoo is now under the Bing Ads umbrella as well. And AdWords is Google's main revenue source. So it's what exists in what's called a virtuous cycle, where because things are good, they keep getting better. So Google shows ads with high quality, that is, they make a lot of money per ad relative to other advertisers, which brings in high revenues. Well, the fact that they keep on making high revenues, that brings in more money that Google can reinvest to make their performance even better in an increasingly complex world, okay? And deliver them faster and all that. For example, you go to Yahoo Finance. Right, so we saw when I run a Google search, boom, it's all right there in a fraction of a second, right? If I go to Yahoo Finance, which is useful for some things, but there's ads, there's like a million ads down here on it, and even this shit takes a while to load, right? Just the cryptocurrency prices, and there's ads on the margins, they take a long time. They're slow, I don't even know how they're, All right? So by comparison, Google has this awesome advanced technology that can deliver stuff really fast. Yahoo, not so much. Okay. The other thing, AdWords is extensible. It's basically a framework of rules that Google can use to take advantage of the expanding online environment. So remember, they started this up in 2000. And two huge things have changed, right, in terms of from 2000. Number one, vastly more users of the internet, right? Basically now the whole world is on. 2000, not so much, right? A lot of people in the United States were on, but worldwide, not so much. The other thing, basically broadband. So Google can deliver a whole lot more ads and can deliver them faster and can deliver them, basically prettier, sparkly, whatever. They got video now, whatever. So those two things. Because there's a lot more users and there's a lot more options and ads, Google figured out a way to make money off of those trends. So, Google wants to maximize its total revenue from ad space, right? Just like a newspaper. Newspapers sell ads and they try to make money off that. So one way to do that is to charge more per unit of ad space. And Google does try to extract, quite a bit from that. But of course, the long-term idea is to prioritize ads that are more likely to lead to sales, which in the long run, Google can expect to charge more for. So if advertisers see, oh, you know what, I paid $1 a click for this ad, but on average I'm making $5 per click, that's great. I will keep on doing that, and I would be willing to bid a little bit more, even than $1. Okay. So, other concerns, number one, Google didn't want to get locked into some kind of suboptimal contract. So, think about how it is with newspapers. They basically have a flat rate per page, right? And you say, oh, I want a half page or a whole page or a little tiny ad. Whatever it is, it's a flat rate. Google doesn't want to do that. Google says, you know what? Some search terms are going to be a lot more likely to lead to sales than others. For example, right? Something like windshield wipers. Actually, you know what the best search is in terms of what people are willing to pay? You guys probably wouldn't guess, but I'll tell you. It's life insurance. Life insurance is a great one, and life insurance companies bid very high for these terms. Reason is, number one, nobody searches for life insurance until they're about to buy it. So you're very likely to be in the market for it when you search. The other thing is, you just buy life insurance for a half hour. You say, oh man, I'm going on that roller coaster, I might die. I'm going to buy a half hour's worth of life insurance. Not usually, right? I mean, you can buy that for a single plane trip, but it's unusual. Most people buy life insurance on the scale of years, right? Possibly for a lifetime. So, if somebody gets that one, click, and somebody goes to their site and buys, a decades-long life insurance policy, life insurance company is going to make a lot of money, and they're willing to pay quite a bit in terms of that click. Okay. Anyway, so back to suboptimal lock-in, though. Think about it. Google doesn't want to charge the same price for life insurance as it does for, say, windshield wipers or something that doesn't even generate any sales at all. For example, right? If I Google pterodactyl, yeah, you might find some ads for stuffies, but probably not, right? Yeah, not seeing any ads. So pterodactyl's one. Google's not making money off that. That's kids looking up Wikipedia to write their science papers or whatnot. All right, so it doesn't want to charge the same for all those. Number two, it wants to let advertisers bid against each other. What's the easiest way to let the price go up without Google having to figure out what the fair price is? Let them bid against each other. Okay? Let the market decide. All right, and some of these other things, like I said, taking advantage of the expanding online domain. If you know that there's going to be more traffic, you know there's going to be more advertisers coming in, then getting them to bid each other is all in your favor. And letting the rates generally float upward, that's also all in your favor. All right, so that's what Google combines in its competitive bidding model. Okay, and then a quick diagram. So, this is the way it works. So, Google has one database full of advertisements, has another database full of search terms. When somebody comes in with a set of search terms and says, I want to Google this, and Google cross-compares the two and says, based on what we know about our ad performance and who you are, we're going to pick some ads for you. And when it generates the page of search results, it's going to sprinkle ads all over. And then the money-making process, if somebody clicks on the ad, then the advertiser pays Google, right? And of course, Google also updates its allocation data. So anytime somebody clicks on an ad, Google recognizes, oh, that's an ad that got clicked on. We should show more of that one, right? Whereas all these other ones that nobody clicked on, relatively speaking, they're falling behind. Okay. Now we can discuss this a little bit. This is an article about a fellow who's renting out cabins. He started early days of AdWords, around 2003. And over the 10 years or so afterward, he went through some changes. So it's posted up on Blackboard. Take a look at it. We can discuss it when we come back on Tuesday. Okay. So that's it for AdWords. Any questions on AdWords? Okay. Next up, AdSense. So AdSense is another customizable model for revenues, right? That's another slice of how Google makes money. So rough number, about probably 15-20% of Google's money. AdWords is around 70-75%. Probably more like 75% these days. Anyway, very similar to print media, right? In the sense that the advertiser doesn't own the space, right? The Chicago Tribune, they run the paper. They want people to buy the paper, but they also run ads on the side. Now, in the newspaper, the Tribune doesn't get paid if somebody clicks on an ad because, in a paper version, because there's nothing to click on, right? Tribune doesn't really know if people buy that product or not. But it charges what it thinks is a sustainable rate, and as long as people are showing up to fill up the newspaper with advertising dollars, yeah, they can get by. All right. So the revenue model for AdSense, somebody has a site, right? Could be a blogger, could be some other site. They agree to display Google's ads. So they designate some rectangular portion of the page and say, run an ad here of such and such dimensions. Then Google's going to select and provide the ads. So when somebody goes to, www.mycrappyblog.com if that blog has agreed to show Google ads, Google will put an ad there whenever somebody loads up that page. And when viewers click the ads, okay, the advertiser pays Google, and Google pays the site owner. Okay. Historical context. This solved the problem of making money from free content. 20 years ago, there were a lot of people slapping up content on the web and trying to figure out how to make money off it. Because the problem is, once you post something online, it's very easy for anybody to copy, right? If it's just text, yeah, somebody can cut and paste that text. If it's video, if it's music, whatever, people can copy that. So, this was a problem. Now always, right, think of models like TV, right? You watch a program on network TV, it plays for like 5-10 minutes, and there's a batch of commercials. So, yeah, this is the same kind of thing, right? The content generates revenue through advertising. But the problem in the online world is that if your advertising is unfocused, if it's not particularly well targeted to what people are looking for, people aren't going to click on it, they're not going to be interested in it, they're probably going to ignore it, and you're going to stop making money. Back in the day, for example, this is how shit was in 1998. You would go to a page, and there would be some little number counter in the bottom, and it would be something like, this page has been viewed okay? It would say something like that, like this page has been viewed some pathetically small number of times. And, you know, within that there would be, here's the content. And up at the top, it would have some kind of banner ad. Yeah, we can do that. Well, let me make it black. And when you got to the page, ooh, it would flicker like this. And it would say something like, congratulations, you are the 10 billionth visitor. Click here to get your free desktop or digital camera. It'd be some crazy nonsense like that. Okay? And what would happen, because you know, you see enough of these things, you're like, well, it's probably bogus, but all right, yeah, I'll check on one. I'll click on one of them. Let's see what happens. Okay? And you know what happens, because I'm going to tell you. You click on that and you get sucked down this rabbit hole of like 25 pages of asking demographic information and product preferences, and you quit, you know, before you even get close to whatever prize they were maybe going to give you at the end, right? Even though they probably was nothing. They just say, well, let's get as much information as we can and we'll wear them out. Nobody's going to do 1,000 pages of questions. So, it's very frustrating. And what happens after you go down one of I'd also point out that, yeah, they did actually have stuff like, you are the billionth visitor, even though down here it would say, yeah, 12 pages, 12, yeah. They would do stuff like that because they're kind of dumb. So as people stop clicking on them, right? Everybody ignored those banner ads. They're like, oh, they're so annoying, they're bogus, they don't do anything. It's like they're not even there. People stopped clicking on online ads at all. So, Google had the wonderful technology that shows fairly relevant ads to what you're searching for nowadays. Okay. Now, in AdSense, the ad selection process is different from AdWords. And the main difference is this. It's based on site content, not search terms. Why is that? Why wouldn't you use search terms? So remember, AdSense is, you know, AdWords gets shown along with Google search results primarily. AdSense gets shown along, let's say, with bloggers. Right? There's other people that use it, but bloggers are a common one. Why wouldn't a blogger, why wouldn't it be appropriate to use search terms? Thoughts? You know, one of the things you learn as an instructor is that 10% of the students are responsible for 90% of the in-class interaction. If you don't have 10 students, then that can drop to 0. Any thoughts? Why wouldn't it make sense to use search terms as the basis for which ads get shown on a blogger's page? Well, let me ask this. Not exactly. How do visitors get to a page with AdWords ads? How do they get there? How do users find themselves in a position where they're seeing AdWords ads? Right. By entering a search, right? A search query. How do visitors get to mycrappyblog.com and see the AdSense ads? How would you get to a web page? That's not what? By clicking it. By clicking what? I mean, how do you get to mycrappyblog.com? What's that? Sure. Type in the URL. That's one possibility. Sure. How else? How else do you get to a web page? Possibly, right? Possibly search-assisted URL entry, right? Because Bing will do that if you type in, it'll like try to put you there. Okay, what else? What's another way to get to a website? Suppose that even though it's a crappy blog, you go there a lot. What might you do to make it easier to get there? You might bookmark it, right? Yeah. Do any of those involve search terms? Not really. I mean, this one, maybe, right? But if somebody just types in the URL, no. How else might you get there? You might get their link from a partner site, right? Like www some other crappy blog. Crappily. Okay? This one, there's no search involved. This one, maybe. And of course, sure, you could look it up through a Google search or through a search. But the point is, there's no guarantee in any of these. When you get to My Crappy Blog, there's no guarantee that a search was involved. Thus, there's no guarantee that there were any search terms at all involved in the process. So Google can't reliably use search terms as the basis for ad selection. Okay, that's why. All right. Anyway, so Google tries to analyze the site content. It tries to figure out keywords, what is this site about? For example, if I wrote a crappy blog, it would probably be about being injured by my children, and yeah, that's probably mostly what it would be about. They took out my eye one time. It came back. I'll show you this. Let's see if I can find it. Ah, there we are. My LinkedIn picture is the top one. Yeah, there was one summer where my kids sent me to the emergency room with like a dented cornea. And so like the first 2 weeks of summer class, I had to wear an eye patch while I lectured. And I thought, you know, I could just wear it for the whole summer class and not like say anything. And everybody would probably be like too scared to ask. But it took it off and told them the story. Anyway, so one of the problems with this content analysis is that matches tend to be less precise, right? It's somewhat hard to assess site content. Basically, you're relying on the person who wrote the site. They come up with a few tags describing their site. And users are more likely to accidentally visit the wrong site than enter the wrong search terms, right? People click on the wrong link all the time, or people enter in a slight, click on the wrong bookmark, type in the wrong address in the URL, things like that. But it doesn't have to be perfect. Google still makes money off this. It's not as good of a process as AdWords. There's some other problems we'll talk about in a minute, but yeah, Google's still making money off of this. And it's very popular with bloggers, right? My Unemployed blog, you know, you can try to make money off ads so you can buy pizza. Promotion aggregators. For example, you might have a site that says about things that you could do when you're on vacation in Hawaii. And on that page, they run a bunch of ads for, you know, tours in Hawaii or plane trips or hotels, stuff like that. And any other kind of informational site, right? Something that's not selling anything, but they still want to make a little money through ads. So, AdSense diagram. This is the Google side, right? So Google has, again, database of ads, basically the same ones that it can run on its other site, that can run through AdWords. And it has a database of web pages, okay? So advertisers send ads to Google. Google has all this information. When somebody visits a page, Google selects the ads, right? It says, oh, here's the page they're visiting. The content, that's all created by the site owner. But the site owner says, you know what? You can place an ad up here. You can place an ad down here. Google's going to look at the same process, right? It's going to try to figure out, based on this stack of ads and what advertisers has bid and what the quality score of the ads is, Google's going to pick a couple of them to show. Now the difference, one of the key differences, in AdSense, there's usually a lot more ads per page, right? You go to a typical search result page, there might be 3, 5, 10 different ads, and that's just on the first page. Subsequent pages, there's going to be more. Usually on a blog page, there's not a whole lot of ads. There's usually fewer, right? Quite often there might only be one. And Google's just going to pick the best one. So that's a little bit of a difference too, but yeah, it depends on the site owner. Okay. So that's AdSense. So we covered AdWords, ads with search results. We covered AdSense, ads running with third-party sites. We talked about why they're different. Questions on any of those? So clicks. There's two big methods when Google gets paid. Number one, when an ad gets seen. So that's what's called pay per impression. So every pair of eyeballs that sees the ad, Google gets paid. The other one is pay per click, right? Not per click, pay per click. Okay, pay per click is certainly the most common usage, right? It's pretty easy to track results because the site owner can, or the advertiser can see, oh, usually it's an advertiser advertising to try to get traffic to their own site so people buy stuff. So the advertiser can see how many people clicked on the ad, how many of those people went on to buy something. They have that information, they can see the value of it. This one, just seeing the ad, the advertiser doesn't get a lot of detail about that. And the other bit, this puts the risk on Google. That's why it's popular. So Google has to go about selecting good ads to run. If an ad generates no traffic to the site, there's no cost to the advertiser. But Google's motivated to get ads that do generate traffic to the advertiser because that's how Google gets paid. Okay? There is another one, what's called pay per conversion. And pay per conversion, basically, Google only gets paid if somebody goes to the site and actually achieves something that the advertiser wants, like buying something or signing up for newsletters or whatever. And that even puts more risk on Google because then Google doesn't even get paid if somebody clicks. They actually have to, complete a purchase of some kind. So you're going to pay extra for that, right? So when a purchase does happen, Google's going to get a bigger slice. So if you're big enough that statistically they're about equivalent, if you have pay-per-click, if you get 1,000 people clicking on your ad and about 50 or 100 of them buy something, you're better off going with pay-per-click. But if you're a very small operation and you're just putting your toe in the water, yeah, you might start off with pay-per-conversion. Anyways, click-through rates are notoriously low. Even if you have a pretty well-targeted ad running along with search, typical numbers between 1 and 3%. If you're above 3%, that's considered quite good. Most other online ads, typically much less than 1%. So we have the double less than, that's way less, like around the order of 0.1%, even including the fact that half of those are accidental clicks. So if it's just untargeted ads, yeah, nobody's going to click on those most of the time. That's where Google really makes its money because the jump from 0.1% to 1%, 10 times more money. 0.1 to 3%, 30 times more money. Okay? That's where the money comes from, is doing a good job of targeting the ads. All right. So let's talk about different kinds of clicks. Let's see if I still got, good, still recording. Okay. I don't know what's going on here. Okay, there we go. I'm not seeing the same things you guys are. It's really weird. All right. Anyway, so Google wants everyone involved in the advertising process to be happy. It wants viewers to be happy. It wants people to see ads that are actually of some interest to them that they might possibly buy something off of. It wants the advertisers to be happy, basically make more money from the ads than they're paying to Google. And Google wants Google to be happy. How does Google get happy? Fat stacks of cash. So, that's what they want. And they've done a pretty good job of it thus far. However, some of the criminally minded among you, with just a little thought, can probably think of some vulnerabilities in the model. And it's always more fun to, try to pick apart a system than to just kind of say, oh yeah, that's great. So, here's one. What if a site owner clicks on his own site's ads, right? Unemployed blogger says, oh man, I'm trying to write this blog and get money to buy pizza, but nobody's visiting, and the people that do visit, nobody clicks on the ads. I'm just going to load up my own page and click on it a few times and get paid $1 a click, and then, I'll have money for pizza. Sounds like a good scam. Yeah, they're watching for that. What about this? What if competitors click on an advertiser's ads? For example, Target and Walmart locked in a battle of whatever, retail proportions. Target might say, you know what, that Walmart, we got to sabotage them. We're going to write a bot that scours the internet, and every time they see a Walmart ad, because we know what sites they're running them on, every time they see a Walmart ad, they're going to generate a virtual click. And Walmart's going to have to pay $1 for that, and we're going to drain all their money from their advertising system. Ha 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 ha. Right? People do stuff like that. Anyway. So Google tries to distinguish between legitimate and illegitimate clicks based on factors like, number one, the volume of traffic, right? For example, unemployed blogger says, oh man, I got away with it. I made $1 last week. I'm going to try to click on it 100 times within the space of a minute and get paid for that. Yeah, that's going to get caught, right? You're just not going to see that. Other stuff, time between clicks, right? So nobody at the same IP address is going to click on an ad 100 times. That would be kind of crazy. Even the time between clicks, right? Typically, during the course of a day, if you're doing some web browsing, even if you do click on an ad, it would be unlikely in most cases for somebody to click on, say, more than one an hour. That would be pretty, in my experience, maybe you guys are, clicking on a lot of ads, but, right, if they're close together and they're repeatedly close together, Google's going to say, no, you're running some kind of scam here. And even the behavior on site, right? If you're an unemployed blogger and you're clicking on your own ads, what are you doing on the site? Well, you don't have much time to do much else, right? You're not browsing the site, you're not going to different pages on it, you're just loading up the page, clicking on the ad, loading up the page, clicking on the ad over and over and over. You're not doing any of the stuff that normal people do. And with the analytics software, Google can pretty effectively judge that too. Can say, yeah, this visitor who's generating all these clicks is behaving like a bot, not like an actual site user. So, any clicks that Google deems illegitimate says, yeah, you know what, this isn't normal human traffic, this is either bot traffic or humans trying to manipulate the system. Google's not going to pay you for that. And that's one of the complaints you see with people using these systems, is they'll say, oh yeah, Google told me, that my projected income for the month was like $1,000, but then they crunched some numbers on it and I only ended up getting 400 because stuff like this. So people get a little disgruntled about it, but that's what happens. Excuse me. I should also mention, this is a big reason why AdWords pays a little more than AdSense. The rates for AdSense aren't quite as high as the rates for AdWords. And the reason is simply, AdWords, it's on Google's site. Google would have to click the ads to generate some more money. Google doesn't have to worry about that level of scammery. And that's why it's only with Google or close affiliates. If Google is pretty confident that people aren't going to do this, then there's less risk. But bloggers, yeah, there's always going to be some risk because, for example, suppose I have a blog about umbrellas and I need a little money and I don't get many visitors. What can I do to generate seemingly legitimate ad revenue. What can I do? www.myumbrella.com. And I can't do it. I can't just sit on one machine and, just click and click and click all day. But what can I do? Yeah. Sure, I could ask some people to, hey, why don't you visit my site? And, hey, maybe click on an ad while you're there, right? What else could I do? Yeah, possibly. I could do that. I could relocate my computer in different places, couldn't I? Or I could go to different computers. I could find public ones like in libraries and go visit my site and then click on something. Maybe get paid for that, right? Yeah, those are the kind of things people can do. And if you're doing it at a small scale, chances are you're going to get away with it, right? Google isn't going to chase you down for like every nickel of revenue they can get. It's not worth the trouble, right? Yeah, a certain amount of that is going to get through. But yeah, if you try to do it, say, oh, all my friends visit the site and all of you click on ads, Google's going to see, yeah, we have like 100 people clicking on the site within the space of an hour and they all clicked on an ad. Google knows that ads only get like, 1 to 3%. So if, 100 people are clicking, you're not going to get paid all for that. But if you have some visitors, and yeah, you tell a couple of your friends, hey, go and click and then, I'll buy you a coffee or something. Yeah, you probably get that. All right. And that's the sort of thing that, yeah, with AdSense that Google kind of has to worry about. It's going to cut into the revenues. Okay. So that's enough about that. That's all the Google stuff, okay? AdWords, AdSense, why they are the way they are. Next thing to talk about, APIs. So, API, the I is for interface. It's an interface between applications based on standard input and output formats. So the idea is you design some kind of generic object that conforms to the standards. And then the designer don't need to know machine-specific details like the operating system or the internet browser being used. For example, an advertising API, right? We have, here's the page, www.mcb.com, my crappy blog. Okay? You've designated some space for the ad, and we'll do that in green. So what's going to be the information? Well, pixel size, location, okay, what else? Type, like image or video. That's pretty much it, right? And one last thing, action on click, okay? So if somebody clicks on the ad, what happens? Does it just show a different picture? Is it a link that sends you somewhere? Things like this. These are the standard things that go into an ad. And so Google can use this format. Google can store ads in one format that contains this information, and then whatever page is there, right? Google says, oh, I pick one of these ads, the input is in a standard format, right? It's an ad, it has a pixel size, has a type, has an action on click. So all that information is there when the ad gets run. Don't need to know who is visiting the page, don't need to know what machine they're doing it on, don't need to know the software they're using. Okay? That's the wonderful thing about APIs. Because imagine if you had to get a custom version of the ad for every possible combination of hardware and software. It would be a nightmare. Instead, this way, there's just one. They design the interface once, and they say, okay, your site has to allow data to be received in that particular format. And then they only have to design it once. Okay, so ad APIs, for example, they pull online ads for a database, and they'll include things like labels and text, size, image and video quality, action on click, right? Those are the standard things that go into an ad that gets shown on a web page. So, for API formats, what are the essentials? Description of the object, right, which basically means the data it can hold and the action it can perform. So, the data would be the image, the video, whatever, and the actions. Does the video play? What quality, how does it play? What format does it use? What happens when you click on it? What happens when it stops? Things like that. And then format for inputs and outputs. So the object and then the format. And there's ways that you can do it, right? So XML we talked about is an object description language. You can use it, but it's out of date. You don't see it much anymore. And JSON, again, compact, still widely used. That's probably what you'll use. Okay. Now, ads as objects. You ever experience this? You're looking at a product on Amazon, you don't maybe add it to your cart, but you don't buy it, and then you go to another page and there's like super creepy ads like, hey, how about this thing that you just looked at on Amazon? Yeah. Okay? That's a thing. So, what happens, Amazon has its own advertising system. They partner up with other websites and basically they have as inputs, right? Again, there's a window in the corner of the web page where Amazon has been enabled to run ads. The inputs are the user history, right, which gets stored as a cookie, basically a data file on your computer. The history is typically going to be an item you have looked at, especially an item you have added to your cart but not actually purchased. So they'll get that from Amazon, from the cookie. Then the actions, right? Pull a current ad image, say, oh, that product, here's the image that we show in the ad, and the clicks lead to being able to buy that product. Okay? Then the outputs from the ad, there's either a response or a non-response. If there's a response, if somebody clicks on it, that's great. Amazon needs to know that somebody actually clicked on the ad is working. In the case of a non-response, right, that's sort of implicit. If somebody just goes on to the next page and doesn't click on the ad, yeah, Amazon will eventually figure that out as well. Okay? Any of those things can update the cookie, right? So if somebody has, for example, skipped over an ad, right? The ad for product A has been shown, but the person didn't click on it. Amazon's eventually going to stop showing you product A, and they're going to move on to product B. And they're not going to keep showing you product A over and over and over and over. They're going to try something else. Okay. Because they know, if you didn't buy it the 5th time, you're probably not going to buy it the 6th time either. Okay. So that's APIs, right? APIs are basically just interfaces between applications. In this case, the applications are the advertising system and the web browser. Those are the two applications. And they're a way to show ads in a standard format, regardless of what device or software is being used. Okay. Next thing, Google's databases. So Google, as you might imagine, has some truly massive databases, right? Things for advertisements, web pages, everything else. But surprisingly, they don't actually use a NoSQL system. They have something called NewSQL, which is kind of intermediate between the two. It does some stuff that you can't get with regular SQL, but still it's fundamentally a relational design. So, for all these databases we're going to talk about, you don't need to be super detailed, you don't have to have super detailed knowledge about it, but you should know which details hold which stuff. So the base platform for Google is Spanner. If you want to think about that, it spans the entire operation. Okay? And on top, you have F1. F1 is the advertising database. Okay, the whole, basically all the ads that Google stores. And I'd take a minute to talk about this. So, main feature of relational databases is permitting join operations, basically where you can cross-compare things in tables, right? So if you have a table of invoices and a table of customers, you can get customer information based on who's actually present in the table of invoices, right? So, for example, show me all the invoices from customers who reside in zip code 60607. You can do a table join to get that. But when tables are very big, and especially if you want to cross-compare everything, what's called an outer join, where you want to verify that every entry in the first table has a corresponding matching entry in the second table, right? That there are none of those loose ends. What's called enforcing referential integrity, when you do that, set up the relationships in Access, that becomes a real problem, right? And it's multiplicative, and basically the computational cost explodes. And if the tables are on separate machines, just forget about it, because instead of having that happen at electronic speed, it's going to happen at mechanical speed, and it's going to take a couple weeks to get done, literally a couple weeks. So, article in Stack Overflow if you're interested in the tech behind it, right? So why do joins reduce scalability in large-scale distributed database systems? If you want to know more detail, there it is. But for now, here's the key thing. Relational databases let you do those join operations, but join operations can be very big and unworkable if the tables are very big, okay? But there are ways to make these join operations happen faster. You can arrange your data smarter. For example, if you can make a compact version, right? Like if all the query fields are combined in a single new table, if you can scrunch down the data that's involved, or you can partition data into matching subsets. For example, right? If you can say something like, So one table of invoices, one table of customers. Suppose you know that you often look for groups of customers by zip code, right? Suppose that's one of like the default common things you do. Then, if you arrange your customers in zip code groups, right? For example, all 60607 customers. Then when you're doing that kind of invoice work, right, that kind of table join, you don't have to involve the whole table. You just have to involve a slice of the second table. And that makes life a lot easier. So if you're doing these kind of table joins on data that's pre-grouped in some useful way, that's one of the things Google does too to make the process happen a lot faster. So even though, yeah, it's a relational database and table joins might be a problem, you can arrange your data smarter to get around a lot of that problem. And that's essentially what Google does. It's a big part of what they do in a variety of ways. They group related data together, so every operation they're doing, they don't have to sort through their whole entire giant database. Excuse me. Okay. So, we'll talk about the databases then. So Spanner's system, it uses SQL, but it approaches NoSQL performance levels in terms of flexibility, in terms of the ability to change data structures. So, one key point though, provides almost immediate consistency as a distributed system. That means even though there are multiple copies of things floating around in different stations and different data centers, even so, something that happens in one database is almost immediately copied to another one, which makes it suitable for transactions. Like we talked about Bitcoin, right? One of the things with Bitcoin, when that hack happened on the Poloniex exchange, they put in a bunch of requests basically simultaneously. Their system couldn't catch up with it. Bad guys walked out with a lot of money. That's the sort of thing you want to stop in a transactional system. Okay, so this one, Spanner, because it provides almost immediate consistency, it's very suitable for running transactions. And that's important for businesses. Okay, the other thing makes it nice for businesses who want to use Spanner. It runs SQL, right? If you have a NoSQL system, you might use a slightly different version of SQL, and so some of the instructions you have coded in your own systems might not work on Google. Google doesn't want that because that's going to drive away most customers. So instead, Google has SQL, right? Everything that's in regular SQL will run on Spanner, but Google also has some additional features that they built in, and if you want to use NewSQL, it extends it. You have those capabilities as well. All right. So, pictures. Everybody likes pictures. So, two axes, consistency, speed, and flexibility, right? We know if you have a traditional relational database, everything's going to be consistent. You're sticking to those ACID properties. You make a change. That's what everybody's going to see. But because of that, when your system gets big, it can run slow. That's why if you have a system that's slow, like imagine for Facebook's, if everything was kept with ACID properties, for Facebook's picture system, photo system, it would be unworkable. So instead, they build in a kind of NoSQL system for that. So it's fast and flexible, and if your operation can tolerate some inconsistency, like again with Facebook, it doesn't really matter if everybody sees the same photo at exactly the same time or the tags on it. It doesn't matter that much, right? Eventual consistency is fine for something like that because there's no transactions involved. Okay. Trade-off between the two, Spanner makes it easy to change your schema because NewSQL allows things to change in a way that regular SQL doesn't, and it allows joins of large distributed tables. And one of the things, and there's mechanisms for grouping data in ways that are smarter, right? Once you figure out, here's something that we're going to group data together by very often, yeah, then you can do that. Even so, it provides strong consistency guarantees. So Spanner is really more on this side, but it is pretty flexible. Okay? You can change stuff in a way that you can't easily do in a relational database of that scale. Okay. So, first one, Google's ad database, F1. It's a very, 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 very big relational database, right? It's highly consistent, even though it's large scale, it's distributed because different, same ads will be stored in different data centers potentially. But like NoSQL databases, it's very scalable. It can run on many, tens of thousands of instances of regular hardware, different servers. So, operational properties. Number one, it's going to be mostly about reading, right? Any ad that gets sent to Google gets written to the database once, but might get read millions of times for a popular search. So Google really wants to focus on the read speed of this system. And especially, it shouldn't materially interfere with search results. So what Google doesn't want is some situation like Yahoo has, where the search results take like 8 seconds to load because Google's waiting on the ads to load as well. That would be unworkable for Google. Write speed, yeah, you want it to be fast, but whatever. Somebody's only loading the ad once, and it's going to take how long it takes. Okay, that's based on Spanner and Bigtable. Okay, but Bigtable we've actually already covered a little bit. If you're interested in more, yeah, there's a couple links, but basically what you need to know for F1, F1 is Google's database for storing ads, and it's essentially a relational database. There's some extended features, but basically a relational database. Another tool that Google has, something called BigQuery. And BigQuery is kind of magical in that it allows fast queries over very, very, very large tables. Okay? So you guys may know that right now, Excel will let you have tables with 1 million rows, right? It's 1 million and some small change because it's like 2 to the 20th, but still 1 million rows. Back in the day, like the Excel version 97, only allowed about 65,000 rows. So if you had a table bigger than that, you needed to split it across tables or have some specialized software developed to let you do that. BigQuery is the same kind of problem because many businesses have piles of data so big that they're not suitable to be, to run queries on them in ordinary software. So that's what BigQuery is. Very useful specialized system. And for most businesses, if you're not fundamentally a data-centric business, using BigQuery is vastly cheaper than building a similar model from scratch, right? So whatever kind of data you're gathering in your business, customer data, supply chain data, whatever, BigQuery is good for that. And when we say very big tables, we might mean like 10 million entries, which is not nearly as big as it used to be. Okay. But even BigQuery has its limits. One of the things for BigQuery, if the query can't run in 30 seconds, then it gives up and quits. Okay, so one of the things that can happen, again, if you're doing like some big table joins, yeah, that can be a problem. All right, now we talk more about BigQuery, but it's kind of techy. But if you want to talk about it sometime, well, you know where to find me. Okay, but here's some key things. So number one, suppose you have one table that's very, very, very large, like maybe 20 million records, and one is small, like say 1,000 records. Well, one of the easy ways to run a query on that is basically to slice up the big table into many small slices and put the entire smaller table along with it, right? And just run a query, that way, all on separate machines. It's like MapReduce, which we talked about. Okay, so again, the simple idea is one big table, one small table, okay? Every time I slice this up, I'm going to take, this plus the whole thing. And then I'm going to run a query on those two together. So show me everything. Whoa, damn. Show me everything that's in that query, and then and then just sum up the results together at the end. So for example, if this is a list of customers, this is a list of invoices, and this is a list of customers. The list of customers is actually pretty small. I can copy over the list of customers when I'm running the query on on each slice of this giant table of invoices. Okay. The other possibility, suppose both tables are very, very large and you want to do some cross table on that. Essentially, what you do, make some super big table containing all the fields of both, and you can try to slice that up as well. But eventually, the super large tables do become too big. They have to be stretched across multiple machines. In the process of breaking them up and copying to machines and reassembling them, you can eventually bump into that 30-second limit. So anyway, there's a little article of guy, well, I don't even know if this is still active. Let's see. It was down for a little while and then, not there anymore. some guys did some experiment on some crazy big tables, running them through BigQuery and said, okay, here's what happens, and here are queries we can run, and here's what we can't. All right. So, key difference between BigQuery and Spanner. They do sound similar, right? BigQuery can process a lot of data very quickly, so can Spanner. What's the difference? Well, Spanner is good for a lot of frequent but fairly simple database operations, like small transactions, right? Like looking up one thing or updating one record. Spanner is great for that. BigQuery is good for infrequent but truly massive database operations, like show me all the customers in this huge database who have bought one of these particular items in the last 3 years. That's something that you're probably not going to want to do with Spanner. That's what BigQuery is for. Okay? Spanner, a lot of very small, simple operations. You want them to happen fast, good for handling transactions. BigQuery, good for big queries. Okay. And a Quora article, if you guys don't read Quora, you probably should. Quora is your friend. There's some funny stuff on there. Rain. Okay. All right. Questions on any of that stuff? Okay. So you need to know what these databases are. I'm not going to ask you detailed questions about how they work, but know what they are and the comparisons between the two. Okay. So next up, data marts and warehouses. So data warehouse basically means the entire stock of data that belongs to an organization. That's the warehouse, that's all of it. A data mart is a subset of a data warehouse. So think like one aisle in a warehouse. And typically it corresponds to a specific functional area, right? So like finances data or marketing's data, things like that. And all this arises through a natural process, right? Basically, different departments gather their own data, they manage it all. When businesses are just starting out, that makes sense, but eventually you got to combine it, right? So combining data in one storage system is pretty easy. It's easy to throw it all together, right? But the problem is different tables can have different permissions. And if you want to have some kind of end-to-end check for, some client comes in and says, I want to know if I can order 1,000 bicycles and can I pay for them with 10% down and will they be here by December 1st, right? That's the sort of question that's going to involve multiple departments with multiple permission levels. And it's difficult to automate. So one of the big trends of the 90s and the aughts was making these kind of common systems like ERP that we talked about. So ERP systems, fundamentally, they bring all of this data together into one common system, right? So it's basically a transition from separate databases for functional areas into one giant database for the entire organization so that everybody seeking an answer, there's absolutely only one correct answer there, and it's accessible. So basically, this allows things like you don't have to push requests through other departments because you can automate that process, and you won't have inconsistencies across departmental databases. So you might have different departments that have different address information or different phone contact for a particular business, right? Because one of them updated the info, the other one didn't, and so you don't know which one is right. So current usage, basically all large businesses these days have an ERP system, and a lot of medium and even small ones do. So ERPs, if I were teaching this class 10 years ago, I would talk about how ERP was a big, exciting trend. But now it's just, you go to a big business, if you work there, they will probably have an ERP system, and this is why. Okay, just a few more slides. So, supply chain management, which I mentioned a few times, but it's basically what it's in charge of is making sure that goods get shipped in the right amounts and at the right time and managing the transactions and tracking data about basically how well the shipping goes. Do things get there on time and intact, stuff like that. So, as a business function, supply chain is going to require a lot of different inputs from different functional areas. For example, from marketing, what's the demand for the product? What's the trend? Is it going up? Is it going down? Is it seasonal? Whatever. With accounting, right, they have to manage these billing problems. And with operations, how much capacity is available? So again, if somebody says, we would like to order 1,000 bicycles, does the manufacturing operation have enough capacity to actually make those 1,000 bicycles, or are they already full up keeping up with orders that have already been put in? Okay? So an ERP system with high database consistency can get these kind of fast and correct decisions. So as long as the information is all there in one place and everything's up to date, and everything is consistent in the idea that you don't have conflicting data within the database, Yeah, you'll get the correct answer and you'll get it quickly. That's the wonderful thing. So this is good, especially for web-based operations, right? If somebody's using a website to check this order, 20 years ago, you might have had to actually call a human and talk to them on the phone, and they'd have to talk to another human behind the scenes. It was a big hassle. But now that these kind of systems are in place, boom, you can just go to the website and you can see, oh yeah, this is when the stuff will be available. So it's great. Okay. So let's talk about a scenario. Suppose you're a business, you have a supply chain application, you're running it under your own roof, you want to migrate it to the cloud. Okay, so the goal, you want to run that same system in the cloud, not under your own roof, you want to run it in the cloud. But the big concern, you can't take your supply chain management system down ever. It has to be up and running all the time, because if you don't use it, then basically you're not making any money. You have to keep it up in order to sustain your operations. So, big picture migration process, how it works to get stuff to the cloud. Basically, number one, clone each component from the internal system to a virtual machine or set of, some virtual machine in the cloud. Then copy data to the cloud. Then test how the whole individual components function, test how the system as a whole functions. And when it works well enough, you use the cloud system and shut down your internal one. So that's the basic, big picture of the process. Obviously, the details are quite complicated, but that's, the flow of how it goes. Okay. Now, a little bit about virtual machines. So when we talk about a virtual machine, virtual in the computing world basically means a computerized version of something. And by computerized, we mean typically exists in software. So when we talk about a virtual server, we mean it's the equivalent of a server. It'll do all the stuff a server does, but it's not based on one actual physical machine. It can be the roles and tasks broken up over many machines, right? Same thing with virtual reality. It's not reality, but it kind of feels like reality, whether you're playing tennis or punching people or whatever people do with those. Anybody have an Oculus? No? No? Yeah, me neither. All right. And machine just means a computer. So virtual machine, that's what that means. So a virtual machine is the equivalent of a computer and could include the hardware, software, or both. Cloud systems are built around virtual machines, right? Number one, it's great for the users. They don't need to know the internal details of the system. Number two, the cloud has flexibility to assign things when and where they're needed. So if there's some part of a computer that's not needed, they don't have to supply it. Excuse me. That's actually one of the big trends these days. So once upon a time, businesses tended to, cloud systems tended to mostly provide virtual machines that would be like the rough equivalent of entire servers or desktops. Nowadays, they typically create much smaller versions that just run single applications, and because that's a lot cheaper to do. Because anytime you set up an entire desktop, there's a lot of operating system overhead that you don't. If all you're going to do with that machine is run Excel, you can have a very simple operating system that just has enough stuff to run Excel on it. All right. Anyway, so suppose you're doing supply chain management and suppose you're shifting it to Google's cloud. What would you want to do? Well, supply chain management operations do tend to generate lots of data. There tend to be many transactions, and you got to track shipping performance as well, right? So which trucks on which roads by which drivers at which times are doing well, which aren't, things like that. And accordingly, for different reasons, businesses decide to use BigQuery and Spanner. So what would you probably do? Well, what makes sense, any kind of transactions, anything that needs to get updated in real time, you'd probably do with Spanner, right? So if you want to check where is product A on its route to destination B, yeah, that's the sort of thing you'd run on Spanner because you're looking for one particular thing. However, if you're doing a big picture analysis, right, which routes are better for which kind of traffic, yeah, that's the sort of thing you'd probably use BigQuery for, not Spanner, right? You have a giant mountain of data because you might have like 5-second intervals of every vehicle on every path for every shipment. You want to analyze that stuff, yeah, you would definitely want to use BigQuery for that, okay? So timing and scale of database updates, again, if it's a small update, you're doing like real-time tracking on a package, sure, do that through Spanner. If you need real-time consistency, like you want to show, I dropped this package off or I handed it off to the next station, yeah, Spanner. But if it's long-term analysis with like big mountains of data, doesn't need to get updated very often, sure, put that in BigQuery. And some things don't need to be real-time. For example, shipment performance, you could probably do batch ads for that over time, right? Like Certain things have to be in real time, like where the package is, because people might want to know that. But as far as some particular driver's performance on a whole route, yeah, you can probably batch add those at the end of the day because they're not going to affect your big picture shipping performance that much. If you got like 3 years worth of data, 1 day's worth of data is probably not going to throw it off very much at all. So not much need for real-time urgency there. Okay. Well, that was pretty quick. You got something of an abbreviated version with fewer pictures and less stories. Questions on any of this stuff? Nothing? Everybody knows everything? We're all good? Okay. Well, then I'm going to halt the recording